So, Chapter 3, Numerical Summaries of Center and Variation. Chapter 3.1 is mainly concerned with the measure of center, which is called a mean, and measure of horizontal spread, which is called the standard deviation. So we're going to discuss those two things now, mean and standard deviation. Now recall that when dealing with numerical data, you need to describe the distribution using the three characteristics. We spent a lot of time on that in Chapter 2, which is shape, center, and spread. In Chapter 3, we will learn to describe the center and the spread, not so much the shape. We're going to assume that the shape is symmetrical. The mean can be thought of as the balancing point of the distribution. The things that I'm highlighting here are the ones that you're likely to see in your homework, definitions in your homework. So pay attention to those, okay? Now, the reason we're not discussing spread so much is because the symmetric distribution means that we're going to use the mean as a good representation of the typical value. Whenever the distribution is symmetric, then we can go ahead and use that symmetric distribution. This is a dot plot of the distribution of ACT students, which is why we're only talking about center and spread, because we're assuming that the shape is symmetric. Okay, we're already assuming that the shape is symmetric. So if the data is skewed, we're not going to use the mean to describe it. Using the mean to describe typical values. So the typical values is a set of data that is roughly symmetric. For skewed distributions, FYI, the mean is not a good estimate of the typical value. To compute the mean for small data sets, simply add the values and divide by the number of numbers. And for large sets, use appropriate technology. Okay, so here's an example. Suppose the sample of prices for 1 gallon of gas, regular gas at 10 different stations is given in this table here. A dot plot will show this is roughly symmetric, so we're going to assume that it's symmetric. Now, to find the mean, we would simply add all of the numbers, and then since this is 10 sets of numbers, we would divide by 10 and get the mean. I want to show you how to put these numbers in a calculator and have the calculator calculate in mean instead of doing it this old-fashioned way here. So go to your calculator, press the stat button, STA, then press edit, number 1. And if you have data in a list, go up to list 1, L1, press clear and enter. And that clears the list. And now you can go ahead and input all of your numbers, 3.19, 3.09. I'm entering all of the data, 3.09, enter, 2.93, enter, 2.95, enter, 3.09, enter, 2.99, enter, 2.99, enter, 2.95, enter, and 2.97, enter. So it seems I have my 10 numbers in there. And then to find the mean, you would press the stat button again, scroll over one to calculate, and we're selecting number one var stats. Enter. We're taking the data from list one, so just keep pressing enter and it will calculate the data for you. So to interpret this data, I'm going to copy this and paste it into our notes as what I got out of the data. Okay, this is what I got from the calculator. Notice that the calculator computed the mean for me. This X bar right here is the mean of the data. Okay, now there's more information here that I'm going to discuss in a little bit, but let's move on. Okay, so what does the mean mean? The typical price of gas was $3.02 on this particular day in 2013. Gas is much cheaper now, right? In case you missed all the instructions with the calculator, these are the instructions here, so you can go back and do it again. Now, measuring the spread. So the variability of a distribution can be measured by using something called the horizontal spread. Assigning a number to this horizontal spread is not straightforward. A standard deviation measures how far from the center the typical observation is. Okay, all of these are definitions. For most distributions, a majority of data is within one standard deviation of the mean. Okay, most data has, most distributions have the data within one standard deviation. Think of standard deviation as the typical distance of the observation from their mean. Now, standard deviation uses a formula. I'm not going to describe this formula to you because it's very complex, and if we use that formula, we would have to, for that example that we did before, this is the amount of calculation that we would need to do to compute standard deviation. Well, that standard deviation is already found in our calculator. We don't need to do all of these calculations. That would be a complete waste of time. The standard deviation is this number, uppercase SX. Okay, that is the standard deviation. So again, we don't need to go over and do everything again or do all of these computations. That would be such a waste of time. So again, this is the calculator version of it in case you needed to use the calculator. And you know, we rounded to two decimal places, and we see that it's 0.09. So at most of these gas stations, the price of a gallon of gas was within 9 cents of $3.02, backwards or forwards. So it could be less 9 cents anywhere, you know, 3.01, 3.0, 2.99, or it could be forward, 3.02, 3.0, 3.10, and so on. But it's typically within 9 cents of that number. Now, something called variance is sometimes used, but the standard deviation is preferred over the variance since it has the same units as the original data set. Variance is standard deviation squared. This is the definition problem that you will see in your homework. All right, so let's go ahead and look at a few of the problems from your homework. I've already copied and pasted some of them here. This is question 6. The first 5 questions are actually definition questions and very easy. Now, question 6, the histogram shows the age of 25 CEOs listed on a certain website. Based on the distribution, what is the approximate mean of the CEOs in this data? So notice that this data is very symmetric, so the mean is right there between 56. This increases in units of force, so between 56 to 60 is the typical age of a CEO here. Question here, the question 7. The list below represents the number of paid vacation days per number for law required by law for different countries. Compute parts 8 to 3. So I'm going to use my calculator to find the mean. Okay, I'm going to go over this process again, clear this, stat. I'm going to clear that list out of there. And I'm going to put in these new numbers. Hold on one second. I got to pull up back the numbers from another page. It would be good if you guys have a calculator and you're using that free calculator app and you're putting in the numbers with me so you can do this easily. 0, 20, 30, 24, 10, and 12. Enter. Then press your stat button. Scroll over to calculate. Press enter. And then keep pressing enter until it computes the data for you. So here's our data that we see for the results. I'm going to go ahead and capture the screen and put it back into our notes so we can make sense out of it. Okay. Capture screen. Let's put that data on the side here. This is from our calculator. And we can see on our data that the mean is 16, so we can go ahead and write in 16. The mean is 16 days. So this means that this is the typical or average number of vacation days. The standard deviation, right there, round to the nearest tenth or to 2 decimal places, so 10.81. I'm sorry, 1 decimal place, right? Not 2 decimal place, 10.8. 10.8 would be our mean, or standard deviation. And now we want to go ahead and answer. So this standard deviation measures how many vacation days, more or less, than the mean the country usually has. Okay, so it will be 16 plus 10.8 or 16 minus 10.8. At their inauguration, the ages of the first 6 out of a current number of 45 presidents of a certain country were 64, 53, 60, 51, 53, and 63. So again, you want to put those into your calculator. I'm going to do it one more time to make sure that you can do it. Stat, edit my list, clear my list, and then enter the set of data. Let me go back to my data here. So 45, 64, these are the ages of the first 6 presidents, 64, 53, 60, 51, 53, and 63. Then stat, calculate, enter, and we're going to go ahead and bring that page over into our notes that we just computed. Let's actions, capture this page, copy it, and put it into our notes on the side here so we can look at it. So from this, we can see that the mean, the very first number to one decimal place, round to the nearest tenth. Pay attention to what they're asking you for the number of decimal places. This obviously means that the most 6 recent presidents, the mean of the most 6 recent presidents, that's than the last 6 that we had, is 58.5. So clearly, the first 6 presidents tend to be a bit younger because their average age was 57.3. Standard deviation came from our numbers right there, standard deviation. And they want it rounded to the nearest tenth, so 5.7. The standard deviation of the most recent 6 presidents was 1.2. So if we compare these two standard deviations, we see that the first 6 presidents tended to have more variation. That their variation was a larger number, their standard deviation was a larger number. Okay, so now I want to go to question 9 in your homework. Question 9, I'm going to go directly to the homework for this one. It's this question, and it has a lot of data, so we're not going to try to enter all of this data in a calculator. Instead, I'm going to show you how to use the embedded program to input the data. College students and surfers Rex Robinson and Sandy Hudson collected data on self-reported numbers of days in a month for 30 longboard and 30 shortboard surface. Completes part A and B. So first they want us to compute the means for both longboard surface. So press the little button that says next to full data set, and we're going to open this data in StatCrunch. So give the program a chance to load, and then you're going to press the Stat button, Summary Stats for columns, and first we're going to find for longboard surface. So press longboard and mean, and we're going to compute the mean for them. So remember, they want the mean, let's see what they wanted in one decimal place, so 13.1. Then I'm going to, so let's go ahead and we can go ahead and enter that, right? So 13.1. Okay. Then I'm going to go back now to answer. They want the mean for the shortboard players. So we're going to go back to this table and we're going to edit the options. Okay. Options, edit, and we're going to do it for shortboard instead and compute. And we see that the mean is 12.7. So we're going to go ahead and enter 12.7 in our answer. And next they're going to ask us to, so first of all, notice here that the longboarders has the larger number, so longboarders tend to go surfing more than shortboarders, yeah? All right, now they want us to compute the standard deviation, so we go back to our program, options, edit, and we press standard deviation instead for longboarders, standard deviation, compute, and we see that it's 5.7219. So we're going to enter, I think they want this to one decimal place. Yeah. Yeah, we're on to one decimal. So 5.7. And they want us to get the standard deviation for the short borders. So we go back to our data, options, edit, and press short board instead and compute. And we see for the short borders, it's 5.4. So clearly the larger number is 5.7. So longboarders tend to have more varied surfing days instead. Okay, so let's go ahead and copy and paste this so you guys can see it. This is question 9. Okay. Okay, then I want to also do another StatCrunch question, which is question 10 on your homework. The college student asked a group of 50 employed students how many times they went out to eat in the last week. Half of the students had full-time jobs and the other half had part-time jobs. So two sets of data here, full-time and part-time. Again, press the little rectangle to copy the table, open it in StatCrunch, and we're going to use this nice handy program to check our statistics, okay? Data, statistics, summary statistics, columns. First, we want the mean for the full-time. Compute. We see that the mean is 3.8. So we go ahead and empty the mean, enter the mean as 3.8. And then we edit the options for part-time. Compute it. And we get for part-time is 2.6. Says do not wrong, so 2.56. 2.56. Therefore, the mean is higher for the full-time workers. Okay. Next, we're going to do our standard deviation. So let's get a couple of standard deviations from the data sets. Options, edit. We need first for full-time, standard deviation, compute, 1.7, 1.7. I think this is 2 decimal places, so 1.71. 1.71. And then for part-time, edit, for part-time, compute, it is 1.45. We're rounding to 2 decimal places, 1.45. So the standard deviation is higher for the full-time students. All right, so we can go back to, we don't need to use StatCrunch anymore. At this point, we can just go ahead and answer some of the other questions. So I'm going to copy these and paste them. Snip this in. Oh wait, this is the wrong problem, not this one. I'm sorry. Yeah, this one. It's question 11. Yeah. We need to bring in the graphs also. Okay, let me copy question 12 since I'm here. And perhaps question 13 as well, so we can wrap this up. Question 13 is the last question, isn't it? Yep. There we go. All right, so we can go ahead and wrap this up here and discuss the last 3 questions from our homework. Let me just make sure that these are numbered. This is 8, this is 9, this is 10. So we're on question 11. Okay, here we go. So a look at the histograms on the right here of real estate and decide whether you think the standard deviation of home prices in city A was larger or smaller than the standard deviation in city B. So city B would have the larger standard deviation. Remember, this city A is roughly symmetric. So because of that, city B would have a larger standard deviation rather than city A. City A is roughly symmetric, so it would have a typical mean. So that takes you to this answer immediately. The prices of houses in city B have a larger standard deviation because the data from CDA shows a lot of prices near the center. This is typical. So that means city B would be the odd one with the larger standard deviation, and city B shows a lot of prices far from the center of the graph. The center of the graph is somewhere about here, and they show a lot of prices, like for example to the left for $2. So very straightforward question. Question 12. The histogram contains data range with a range of 1 to 6. Which group would have a larger standard deviation? Again, this data here is roughly symmetric. The first graph is not, so group A clearly would, this is roughly symmetric, so this is typical. So group A would have a larger standard deviation. That would be your correct answer. There are more observations far from the mean. None of the other answers have group A. This has group B. This has group B. But it wouldn't, the larger standard deviation would be the one that is not typical. Okay. Finally, question 13. The mean birth weight of children in a certain country full term after 40 weeks is 3.49. So the mean is 3.49, about 7.7 pounds in context. The standard deviation is 450 grams. And the shape is symmetric and unimodal, complete parts A and B. So the top value is simply 3496 plus the standard deviation, which is 3946, and the bottom value is 3496, the mean minus the standard deviation, which is 3046. Is a birth weight of 2900 more than one standard deviation below the mean? So one standard deviation below is 30.46. 2900 is less than one standard deviation of 30.46. So yes, it's more than one standard deviation below the mean.